Hi students, now I am going to discuss your Neet mark test conducted by Myrank online classes. Now, question number 151. Consider the following sets of quantum numbers. Here, the four sets of quantum numbers are given. Which of the following sets of all electrons is not allowed set of quantum numbers? Here, which of the following set of quantum numbers does not exist? Which of the following set does not exist here? Now, first one here, what is given? N is equal to 3 is given. If N is equal to 3, L value given as 0 and M value given as 0 and S is plus half. Okay, so it is possible. N is equal to 3 means L value can be 0, 1, 2 and M value can be 0. Different values possible here because L is equal to 0 means M value can be 0. So therefore, this one correct possible. Next one is the second one. If you see, N is equal to 2 is given, L is equal to 2. If N is equal to 2, L should be less than 2. Therefore, this quantum number set does not exist. Third one, here N is equal to 4 is given. Fine. L is equal to 3 is given and M is equal to -2 given, S is equal to, so it can be plus or minus half. Therefore, this one possible. So therefore, here the third one, clear the possible. And when you see the fourth one, N is equal to 1 is given, L is equal to 0. Yes, it is possible. If N is equal to 1, L is equal to 0. But M is given as -2. So therefore, this one will not exist. Therefore, fourth one not possible. And the fifth one, N is equal to 3 given, L to 2 given is possible. M is equal to 3 given. M value cannot be more than 2 L value. So therefore, this one again not possible. So therefore, second one clear, the third one, second one, fourth one and fifth one not possible. Second one, fourth one and fifth one not possible. Therefore, this one is your correct option. Next one, the question number 152. The major product of the following reaction is, this reaction is Gabriel thalamide synthesis. This reaction is which one here? Gabriel thalamide synthesis. Very, very important one. Gabriel thalamide synthesis. This reaction is used to prepare only aliphatic primary amines. Aliphatic primary amines. This reaction is to prepare only aliphatic primary amines, and aromatic primary amines cannot be prepared here. Now, when this is thalamide, the name of the compound is thalamide. When thalamide react with the KOH, thalamide reacted with simply KOH. Then what do you get here? The thalamide with KOH, you take the thalamide, C double bond O, here this is N, here the H, thalamide. When reacted with KOH, first step reacted with KOH, the potassium thalamide is formed, C double bond O, and N, clear the minus K plus, this is potassium thalamide is formed. And when the potassium thalamide reacted with, so here bromine attached to benzene ring, the next one is here the chlorine attached to the normal carbon. So this is aliphatic and this one is simply clear the aromatic. Therefore, aromatic halides will not involve in the reaction. Only aliphatic halides involve in the reaction. So therefore, here K plus from here and Cl, this is eliminated, and the product is what is formed here. The product is now double bond O, N CH2, this one is true. Actually, the bromine is better leaving group than chlorine, but the bromine attached to aromatic ring, and the next one is the chlorine attached to aliphatic ring. So therefore, the aliphatic one will involve in the reaction. So therefore, your answer is which one here? This one. NCH2, CH2, Br. So therefore, your answer is so first option is your correct option. And next one, question number 153. The correct order of matching of complex compound in column 1 with the properties in the column 2. The first one is A is given as CrNH3 taken 6 plus 3. Here oxidation state of chromium is plus 3. Chromium is in plus 3 oxidation state. The chromium plus 3 oxidation state means, so chromium plus 3, the configuration is clear the 3D3, 4S0 and 4P0. So 3D3 means, if you see here, how many electrons? 1, 2, 3 electrons. Now here d orbitals available for bond formation. Hybridization can be D2, sp3, and n is equal to 3. It is paramagnetic. So paramagnetic, and the next one is octahedral complex. Paramagnetic and octahedral. So therefore, this is paramagnetic and octahedral complex. And the next one is the second one. If you see, second one is A is matched with clear the R. A is matched with R. B, the COCN taken 6 minus 3. The cobalt is in plus 3 oxidation state. Cobalt is in plus 3 oxidation state. The normally cobalt is 4s2 3d7, and this one is 3d6 4s0 and 4p0. 3d6 CN minus is strong field ligand. This is strong field ligand. Therefore, pairing takes place against to clear the Hunt's rule. 1, 2, 3, 4, 5, 6. And d orbitals and p orbitals are there. Hybridization simply D2 sp3 hybridization, again octahedral, but n is equal to 0, and which is simply diamagnetic. Octahedral and diamagnetic. B is clear the matched with which one? Simply Q. A is R and the B is Q. Third one is NiCN taken 4 minus 2. Now the C is NiCN taken 4 minus 2, and here the CN is strong field ligand. Ni is in plus 2 oxidation state, you know, CN minus 1, 4 CNs minus 4, nickel plus 2, therefore minus 2, nickel plus 2. The configuration is, actually nickel is 3d8, 4s2, and 2 electrons will go. The configuration is clear the 3d8 and the 4s0 and the 4p0. And the CN is strong field ligand, therefore pairing takes place against to Hunt's rule 1, 2, 3, 4, 5, 6, 7, 8, and the hybridization can be clear the DSP2 hybridization, because coordination number 4 hybridization is DSP2, and n is equal to 0, and the geometry is square planar and diamagnetic. Square planar and diamagnetic. Fourth one is NiCl taken 4 minus 2, same nickel plus 2 configuration. This is 3d8, 4s0, 4p0. Cl minus is weak field ligand, you know, Cl minus is weak field ligand. As the weak field ligand is there, no pairing takes place. No pairing possible here. 1, 2, 3, 4, 5, 6, 7, 8. N is equal to 2. 2 unpaired electrons are there. Clear, 2 unpaired electrons are there. And the 4s and the 4p. Hybridization is sp3. This is paramagnetic and tetrahedral. Paramagnetic and tetrahedral. And if you see this one here, see, NiCN taken 4 is the square planar diamagnetic, C is matched with S. This one is tetrahedral and paramagnetic, D is matched with simply Q. Therefore, the correct option is 3. Next one is question number 154. Now, I3 minus has. So, I3 minus total number of valence electrons. So, total number of valence electrons, how many are there? So, 3 into group number of iodine 7 plus minus 1 means 1 electron extra. 22 electrons are there. Based on this one, we'll write Lewis-Dot representation. Iodine, iodine, iodine. In the Lewis-Dot representation, the terminal atom must obey, whatever may be the terminal atom, it must obey octet configuration. Therefore, 8 electrons. Again, here it must obey octet configuration, 8 electrons. And next one is the iodine, leftover electrons, 2, 4, 6, 8, 10, 12, 14, 16. So therefore, more 6 electrons available. You must write the 6 electrons on the iodine. Now, the central iodine has 2 bond pairs plus 3 lone pairs. 2 bond pairs plus 3 lone pairs. And if you see the geometry of structure of I3 minus 1 iodine, 1 lone pair. In sp3 dehybridization, lone pairs occupy equatorial position and the iodines occupy simply axial position here. Hybridization is sp3 dehybridization. Geometry is linear. It has 3 bond pairs, it has 3 lone pairs and next one is 2 bond pairs. So now we'll see the options. 5 equatorial lone pairs, no, wrong. 3 equatorial lone pairs are there. 2 axial bond pairs are there. 5 equatorial, wrong. 3 equatorial lone pairs on the central atom, 1 at iodine atom, and 2 axial bond pairs. Yes, this is correct one here. 3 equatorial bond pairs and the 3 equatorial lone pairs and the 2 axial bonds pair present here. Your option is, third option is correct one. Next one is question number 155. Now, the cyclotrimetaphosporic acid. Actually, here metaphosphoric acid is metaphosphoric acid. So, metaphosphoric acid is HPO3. Cyclic trimetaphosphoric acid. Tri means 3 metaphosphoric acid. Cyclotrimeta, here the phosphoric acid. Cyclic trimetaphosphoric acid means here HPO3 taken thrice, it is a trimer. Therefore, then what do you get here? Structure of this one you have to write POO, next one PO, like this. And next one is double bond OH, double bond OH, double bond O and OH. Like this one, how many sigma bonds and how many pi bonds? Just you count here, 3 pi bonds are there, which is not required. Sigma bonds, 1, 2, 3, 4, 5, 6, 7, 8, here 9, 10, 11, 12, 13, 14, 15. Between OH bond also. So therefore, 3 sigma bond, 3 pi bonds, and the 15, here the sigma bonds are there. So therefore, the cyclotrimetaphosphoric acid is HPO3 taken thrice and the 15 sigma bonds. This is very, very important one. The number of POP bonds 3, number of P double bond O's also 3, number of POH bonds also 3. So POP bonds 3, P double bond O bonds 3, and the POH bonds how many? Here the 3. And this is very important one. Number of pi bonds 3, 15 sigma bonds are there. And the structure of this molecular formula is HPO3 taken thrice. So next one is question number 156. Now, for the given reaction, consider the statements 1, 2, 3. So what is this reaction here? In this one, benzene diazonium chloride, BDC is electrophile, and OCH3 is nucleophile. One is electrophile, one is simply nucleophile. And the reaction is nucleophilic, electrophile, nucleophile. The reaction is electrophilic substitution reaction. Electrophilic substitution reaction. In electrophilic substitution reaction, here sigma complex is formed or VLAN intermediate is formed. Now here this electrophile attacks at para position to this one. Electrophile attacks at simply para position. Now the strength of electrophile, reactivity of electrophile can be increased by which group here? The minus Me group. So minus mesomeric effect group will increase the reactivity. And the next one is minus mesomeric effect will increase reactivity. Means nucleophile should have more negative charge, electrophile should have more positive charge. So electron, clear that this one is plus mesomeric effect will increase. Here minus mesomeric effect will increase the reactivity of benzene diazonium ion, whereas here plus mesomeric effect will increase the reactivity of the nucleophile. Very simple here. Then more charge should be there on the electrophile and nucleophile. So here more charge must present. More charge must present on electrophile and nucleophile. Therefore, nucleophile must be attached to which group here? This one. Look at here. The presence of NO2 group in aromatic ring 1 will increase the rate of reaction. No, NO2 is this which group here? Minus mesomeric effect group. Here what should be there? Plus mesomeric effect should be there. So therefore, the first statement is clear, the false statement. Presence of NO2 group in aromatic ring 2 will increase the rate of the reaction. Yes. Here the minus group is there on this electrophile, therefore which will increase the reactivity. True. Third one is in this reaction, VLAN intermediate is formed. Yes. So in electrophilic substitution reaction, then what is the reaction formed here? In this one, electrophilic substitution reaction is there. Sigma complex is formed or VLAN intermediate is formed. This statement also, here the true statement only. The first one is false statement, second one true statement, next one also true statement. So therefore the correct answer is false, true, true. The third option is correct option. This is important question. And the next one is question number 157. Decron is a condensation polymer of. The decron is a condensation polymer of. This is purely clear the memory is bit here. That this is condensation polymer of ethylene glycol and clear the decron. Condensation polymer of which one? Simply the ethylene, clear the glycol and decron. So simply here ethylene glycol, the CH2, clear the CH2OH, and this is ethylene glycol plus terephthalic acid. Phthalic acid is 1,2-dicarboxylic acid. Terephthalic acid is 1,4-dicarboxylic acid. And the during polymerization reaction here, this is C double bond O, clear the O, CH2 and the CH2O. And here also C double bond O and O, CH2 and CH3, CH2, and the polymerization takes place. This is called simply decron. Decron is a polyester. Decron is a simply polyester. This is polyester. Polyester, polyamides will be there. This is polyester, and this is ethylene glycol and phthalic acid. So therefore, very important one. Decron is a polymer of ethylene glycol and terephthalic acid. The next one is the question number 158. Now, glycerol can be separated from spent lye in soap industry by using. Till here, then you take any oil. You can take coconut oil, groundnut oil, linseed oil, any oil. When react with sodium hydroxide, this reaction is called submodification reaction. Then we get soap plus glycerol. CH2OH, CHOH, and CH2OH. This is glycerol is formed. So when the oil reacts with NaOH, soap plus glycerol is formed. Then how to separate soap and clear the glycerol? These two means the glycerol dissociates below its boiling point only, like H2O2, glycerol dissociates below its boiling point. Therefore, by normal distillation method cannot be used. Therefore, normal distillation method cannot be applied. So therefore distillation under reduced pressure. When the pressure is reduced, boiling point decreases. Therefore, the distillation under reduced pressure is used here. Distillation under reduced pressure is used. Distillation under reduced pressure is used. Okay, this is next question is question number 159. When 2-butane is treated with 2-butane CH3 C triple bond C CH3, when 2-butane is reacted with hydrogen palladium barium sulfate, this is Lindelar's catalyst. Second one is sodium liquid ammonia. Okay, so here this hydrogen palladium barium sulfate, this addition is, which addition? Simply here the syn addition, and this is anti addition. The syn addition will give the CH3C hydrogen double bond C, CH3 and hydrogen. This product is cis product, and the CH3C hydrogen double bond C, hydrogen CH3. This is which product here? The trans product. Cis product, and this one is simply the trans product. Now, so what are the given options you see? The first one is X has higher dipole moment and higher melting point. So here this is X and this is Y. So here X generally has high dipole moment, boiling point, and the Y has high melting point. So boiling point of cis compound is more, and the melting point of trans compound more. X has higher dipole moment and higher melting point. First one is not correct one. X has lower boiling point. No, X has high boiling point. Dipole momentum more, boiling point also high. So therefore wrong. X has higher dipole moment and higher boiling point. So therefore third option is correct one. X has higher dipole momentum. The dipole momentum is high, the boiling point also high. So therefore X has higher dipole moment and high boiling point. Okay, so this one. Next one is question number 160. Now, 10 grams of binary electrolyte. The binary electrolyte means AB is binary electrolyte, A plus and B minus. When dissociates, A plus B minus, N is equal to 2, number of ions produced 2. And the weight of solute is, how much? A is equal to 10 grams. And the gram molecular weight of solute, you write the given data, is 100 grams. 10 grams of binary electrolyte is dissolved in 500 grams of water. The freezing point of the solution is given. The degree of ionization of the electrolyte. You have to find. So degree of ionization of electrolyte. So weight of solvent is given 500 grams. Degree of ionization alpha is equal to, you have to calculate simply alpha value. Okay, now the first one, that TF is given, freezing point is minus 0.744 degrees. Therefore, delta TF is equal to, because water is taken, delta TF is, freezing point of water is 0 and this is minus 0.744. So delta TF is equal to 0 minus of minus 0.744, which is equal to 0.744 is delta TF. Now, so delta TF is equal to, what do you get here? Delta TF is equal to Kf into molality A by M into 1000 divided by B into Vanta factor I. This is clear, the delta TF value. If you substitute delta TF value, this value is 0.744. Kf is equal to molar depression constant 1.86. A by M 10 divided by 100 into 1000 divided by 500 into Vanta factor I we have to calculate. So 500 ones, 500 twos, 0, 0, 2 ones, here the 2 fives, 5 ones, 5 threes, 15, 5 sevens, 35, 5 twos. So therefore, I is equal to, this one cancel, we get simply 2. I is equal to 2 means alpha is equal to, in case of dissociation, I minus 1 by n minus 1. Alpha is equal to I minus 1 by simply n minus 1. So I is equal to 2 minus 1. Already I have taken binary, means n is equal to 2, 2 minus 1. So therefore here alpha is equal to 1. Alpha is equal to 1 means the percentage is equal to, alpha percentage is equal to 1 into 100, which is equal to 100%. So therefore, degree of dissociation is 100%. It dissociates to maximum extent. It is strong electrolyte. And the next question. Question number 161. Now, the question number 161. So one important point is, so here answers are in Simon meter square. Simon meter square. That's where units are very important one in this. The particular resistance of a conductivity cell. Resistance of a conductivity cell filled with a solution of an electrolyte of concentration 0.1 m. M1 is given 0.1 m. Its resistance R1 is 100 ohms. In a cell, 0.1 m electrolyte is taken. Its resistance is simply 100. The conductivity of the solution is specific conductance. Conductivity is nothing but conductivity is 1.29 by the Simon meter inverse. This is first one. Resistance of the cell filled with 0.02 m is R2 is 520 at the ohm. See, if the concentration is 0.1, resistance is 100 ohm. The concentration is 0.02, resistance is simply 520 ohm. The molar conductivity, so lambda m of 0.02 m solution, how much? Then we don't know the K2 of this one. K1 we know, K2 we don't know. Lambda m we have to find. So lambda m of 0.02 m is equal to K into 10 power minus 3 divided by, clear the molarity. This is K2 into 10 power minus 3 divided by M2. K2 into 10 power minus 3 divided by M2. So why we have taken K2 into 10 power minus 3 means, so here K is given in, clear the Simon meter inverse. Whenever K is given a Simon meter inverse, this is the formula. And the lambda m is equal to K into 1000 divided by, clear the m, when K is given in, clear the Simon centimeter, clear this one is not Simon, this one is Simon centimeter inverse is given. You have to use this formula, but the data is given in meters, use this formula. Then how to calculate? M2 we know 0.02, K2 we don't know. But how can we calculate K2? Cell constant G star is equal to R1 K1 is equal to R2 K2. And R1 is 100, K1 is 1.29, and R2 is 520, and K2 we don't know. Therefore, K2 is equal to 100 into 1.29 divided by 520. And if you substitute this K2 value in this equation, and now lambda m of 0.02 m is equal to K2 is 100 into 1.29 divided by 520 into 10 power minus 3 divided by 0.02. And if we simplify this one, we get 124 into 10 power minus 4 Simon meter square mole inverse we get. So therefore, this is very important. When the meters, unit is given in meters, you have to take this formula. When the unit is given in centimeters, you have to use this formula. So this is very, very important. 124 into 10 power minus 4 Simon meter square and mole, clear the inverse. The next one is question number 162. When an excess of very dilute solution of Ki. So this is Ki aqueous plus AgNO3 aqueous. When these two combine, we get AgI precipitate is formed plus KNO3 aqueous. This is AgI precipitate. Now from this, when you take excess Ki, AgI, either Ag plus will be accumulated on this or I minus will be accumulated. As the excess Ki is taken, AgI and next one is here, I minus will be accumulated. When excess AgNO3 is taken, AgI as it is, and this one surrounded by Ag plus 1 accumulation. Accumulation of either A plus or I minus takes place. So when the excess AgNO3 is taken, so this one is formed. When the excess Ki is taken, AgI minus is formed. This is the negative colloid, and this is the positive colloid. This is negative colloid, and this is simply the positive colloid. The answer is AgI I minus. This is simply the correct answer. Question number 163. Now, among the following, the incorrect statements. Incorrect statement. So, which is incorrect statement means barium sulfate is most soluble in, clear the H2O, among alkaline earth metals. So, BaSO4 is most soluble. Actually, here the solubility of sulfates of second group alkaline earth metals decrease from beryllium to magnesium sulfate, magnesium to calcium sulfate to barium sulfate. Here, beryllium is small in size, high hydration enthalpy will be there. Because of high hydration enthalpy, the beryllium sulfate is soluble and the barium sulfate is simply insoluble. So therefore, the barium sulfate is most soluble in H2O among alkaline earth metals. The statement is the incorrect statement. Therefore, your answer is the first option. And the next one is question number 164. Choose the incorrect statement. Again, choose the incorrect statement. The stable allotropic form, the stable allotrope of sulfur at room temperature is orthorhombic. Yes, orthorhombic. And it transfers to monoclinic sulfur at 369 Kelvin. This is called simply transition temperature. This is called transition temperature. Correct. First statement correct. White phosphorus is soluble in water but insoluble in CS2. So here, white phosphorus is soluble in carbon disulfide and insoluble in water. But the given statement is reverse. White phosphorus is soluble in water is given. So therefore, second one is wrong statement. And your answer is, which is your correct option here? The second option is your clear the answer you have to choose at the second option. Question number 165. Now, step 2 reactions are given. One is S plus COF3. COF3 is very good fluorinating agent as well as oxidizing agent. We get SF4 plus COF2, we get SF4 plus COF2, we get. And the next one is, this is A. SF4 and this is A. The equation not balanced, not required. The CH3Cl when reacted with COF2, the product is CH3F plus COCl2. This is compound B. A is COF2, B is CH3F. So A is COF2, the correct statement only. The magnetic moment of A is, what is A? Cobalt plus 2. So 3D7, 4S 0. 3D7 means 1, 2, 3, 4, 5, 6, 7. N is equal to 3. Mu is equal to root of N into N plus 2. So therefore 5, 15, root 15 is 3.87 BM Bohr magnetons. Therefore second one also correct only. Step 2 is an example of halide exchange. Yes, this is an example of halide exchange. Chlorine is replaced by fluorine. Therefore, this is also correct only. B has more dipole moment than CH3Cl. B is CH3F has more dipole moment than simply CH3Cl, which is greater. Mu of CH3Cl is greater than CH3F. The exceptional case, due to CCl longer bond, dipole moment of CH3Cl is greater than CH3F. Therefore, fourth statement is wrong statement. First, second, third statements are correct statements. Therefore, your correct option is the first option. Question number 166. Among the following, the number of compounds which undergo hydrolysis is. The first one, how many compounds can undergo hydrolysis? NCl3, you know very well, it can undergo hydrolysis. I don't write the balanced equations here. NH3 plus, where the HCl is obtained. NH3 plus, clear the NCl3 when reacted with simply H2O. Clear the NCl3 plus H2O. NH3 plus, clear the HO, Cl. And from HOCl, again HCl plus nascent oxygen will be produced. First one, it undergoes hydrolysis. And the P4O10, when the P4O10 undergoes hydrolysis, the product is H3PO4, phosphoric acid can undergo hydrolysis. SiCl4, silicon tetrachloride can undergo hydrolysis. To produce SiOH taken, clear the 4. Again, this one can undergo hydrolysis. And xenon tetrafluoride. The xenon tetrafluoride, the reaction is interesting reaction, disproportionation reaction. Xenon trioxide, where the xenon plus, where the HF is formed here. This is clear, that can undergo, this one also can undergo hydrolysis. And the next one, POCl3. Yes, POCl3. When the P4O10 is there subject to hydrolysis, we get H3PO4. Similarly, POCl3 subjected to hydrolysis, the product is H3PO4 is obtained plus the HCl is obtained. And the diborane B2H6, this is important reaction. When the B2H6 subjected to hydrolysis, boric acid is formed, H3, here the BO3 is formed. So therefore, so all the 6 compounds, 1, 2, 3, 4, 5, 6, all the 6 compounds undergo hydrolysis. Therefore, your answer is here the 6. Important one. Their hydrolysis products also very, very important one. And the next one is 167. Choose the pair of species which are colored and paramagnetic. Just look at here. One is KMNO4. Second one is K2MNO4. K2MNO4. Third one is K2CrO4 and K2Cr2O7 and NO2. Total we have 5 compounds, paramagnetic as well as colored. You take NO2, you know very well, which is paramagnetic and colored. Paramagnetic and colored, this one. And the manganese +7, manganese +6, chromium +6, chromium +6. Manganese +7, N is equal to 0, N is equal to 1, N is equal to 0, N is equal to 0. So this is diamagnetic, paramagnetic, diamagnetic, diamagnetic. But all these are colored due to charge transfer phenomenon. All these are colored due to charge transfer phenomenon. So therefore, which are paramagnetic? K2MnO4 and NO2. These two are paramagnetic as well as colored. Therefore, K2MnO4 and NO2. The fourth is your correct option. Question number 168. Devise a series of reactions to convert benzene into metachlorobromobenzene. Metachlorobromobenzene. The given compound is where the benzene converted into metachlorobromobenzene. Chlorine here, the bromine here, metachlorobromobenzene. So how to convert benzene to metachlorobromobenzene? Here we have to perform the chlorination reaction, bromination reaction, and you have to introduce the group at the position means you have to subject it to nitration reaction also. When subjected to concentrate HNO3, then what do you get here? We get nitrobenzene is obtained. So therefore, the first one is, this is nitration is 8th one, HNO3, H2SO4, 8th one, first 8th. Next one is, so here, then Cu2Br is there. This is brominating agent. That's why we have to introduce chlorine into this one. How can we introduce chlorine into this one? When react with the chlorine plus FeCl3. Which one? Chlorine, FeCl3, second one. Because bromination is here, bromine is there, Sandmeyer reaction is therefore introduce chlorine into this one. The NO2 group is which directing group here? Meta-directing group. Therefore, coming electrophile goes to meta position. And the next one is, then this one convert into, if you want to introduce bromine, disonium must be formed. NO2 convert NH2, NH2 must be converted disonium ion. So therefore, reacted with hydrogen platinum catalyst. Hydrogen platinum catalyst. Then when hydrogen platinum catalyst is taken, this chlorine remains same and this one converted into NH2. Next one, when reacted with, converted into diazodization, NaNO2 plus HCl, disonium ion. Then what do you get here? N triple bond N plus the Cl minus disonium ion is formed. And which are reacting with Cu2Br2. This reaction is called Sandmeyer reaction, which is called simply Sandmeyer reaction. We get this product. So therefore, first one, 8th one, next one, second one, and this one is hydrogen. This is the 4th one, and next one, NaNO2 HCl, 3rd one, and the Cu, clear the Cu2Br2 and HBr. This is simply the 9th one. Therefore, 82439, 82439. So therefore, fourth option is correct option. Like this one, nitrobenzene 2, metachlorobromobenzene is obtained in multiple steps. Okay, and the next one is Question number 169. The major product of the following clear the conversion is here OCH3 group is there and here alkene is there and excess bromine is taken. The bromine can attack on the unsaturated carbons. Bromine can attack at ethereal carbon also or ethereal oxygen also. But here O minus is there. Therefore, O minus can combine with simply clear the H plus. And the next one, HBr, addition of bromine according to clear the Markovnikov rule. The negative reagent added to the carbon, clear which is having less number of hydrogens, but both have less number of hydrogens only. But the benzylic carbon is more stable. This is clear the more clear the stable as the benzylic carbon is more stable. Clear HBr attack, Br minus attacks on this carbon. Okay. So therefore, when the Br minus attacks on this carbon, H plus will attack on this. And the next one is one more mole if you take here. See, this is OCH3. Okay, and the next one is CH, double bond CH and CH3. Now, when it is reacted with HBr in excess, this one is replaced by H and this one HBr is added to this one. Therefore, the product is OH. Next one is CH, CH3 and 2. So therefore, the OH and the Br attached to benzylic carbon. OR attached to which one simply? The benzylic carbon. Therefore, what is the correct option here? OH, Br attached to benzylic carbon. Therefore, second option is the correct option. And the next one is question number 20. Question number 170. Now, the increasing order of the reactivity of the following compounds towards electrophilic aromatic substitution reaction is. So very simple here. The increasing order of reactivity of the following compounds towards the electrophilic aromatic substitution reaction is. Electrophilic aromatic substitution means the electron withdrawing group and electron donating groups. So in the electron withdrawing and electron donating groups, if you take here, and the CN is, so this is minus mesomeric, clear the effective group here, minus mesomeric effective group. And the next one, this is also minus mesomeric effective group. This is plus inductive effective group. And therefore, minus mesomeric effective means the reactivity is very less. Here, this one is having the least reactivity is the fifth one, the least reactive one. And the next one is minus mesomeric effect, the fourth one, more reactive one. And the next one is, so here, the first one, no donating, no withdrawing. Therefore, this one is, then you see this is plus inductive effect is there. As the plus inductive effect is there and its reactivity. Now, minus mesomeric plus inductive effect. So here, in case of first one, minus mesomeric will decrease the reactivity, and this will increase the reactivity. Okay, now therefore the fifth one is least reactive, next one fourth one, because whenever electron withdrawing group is there, the reactivity towards electrophilic substitution decreases. So that's why fifth one least reactive, and the next one is the fourth one least reactive, and the first one here, this is again which group here, minus inductive effect group is there, and therefore this is where the least reactive. And the second one, no group is there, therefore it is where the more reactive. Third one, plus inductive effect is there, therefore this is simply where the more reactive. Third one is where the most reactive. This is the reactivity order, fifth one, fourth one, first one, second one, third one. So therefore, the correct option is then the first option. Question number 171. Now, a sample of N2O gas occupied, say, a volume of 0.1 meter cube at 684 mm of Hg, and the pressure is given 684 mm of Hg. Then you convert into atmosphere 684 by 760 mm of, sorry, this is atmospheres I have converted. And the volume is 0.1, clear, the meter cube is given, and if you convert into, clear, the liters. So 0.1 into 1000 decimeter cube, which is equal to 100 liters. And the temperature is 87 degrees centigrade plus 273. So therefore, 360 Kelvin temperature here. Okay, 360 Kelvin temperature. The number of molecules present in the gas sample is the number of molecules here. The number of gas molecules, how many? Number of gas molecules. How many gas molecules are there? Mainly, PV is equal to N into R into T. PV is equal to nRT. PV is equal to nRT. N is equal to number of moles PV by, clear, the RT. Okay, number of moles. N is equal to PV by RT. And this is number of moles. Next one, the number of molecules is equal to number of molecules we need, not moles. N is number of moles. Number of molecules is equal to N into Avogadro number. N into Avogadro number. Therefore, PV by RT into Avogadro number. What is the pressure here? Pressure is 684 divided by 760. Volume is 100 liters by R is 0.0821 liter atmosphere. Temperature is 360 and 6 into 10 power 23. Avogadro number is 6 into 10 power 23. Here, pressure is given, volume is given. Next one, N, Avogadro number. R is universal gas constant, and the temperature is the 360 degree centigrade. So therefore, if you multiply this one, if you simplify this one, we get 1.8066 into 10 power the 24 we get. So therefore, your answer is 1.8066 into 10 power 24. So these many N2O molecules are there in the given problem. PV is equal to nRT only. From this, we have calculated number of moles N value. If you know the number of moles N value, we can calculate number of molecules, that is number of moles into Avogadro number. Okay. And the next one is question number 172. No, the question number 172. The reaction A plus, clear, the B. The reaction is, clear, the A plus 2B gives C is an elementary reaction. Okay. So the reaction is A plus 2B gives C is an elementary reaction. So order with respect to the A is 1, with respect to the B is 2. In experiment involving this reaction, the initial partial pressure of A and B are, clear, the 0.4 atmosphere and 1 atmosphere. Next one is respectively. When the pressure of C becomes 0.3 atmosphere in the reaction, the rate of the reaction relative to the initial rate. See the question carefully. The reaction is given, A plus 2B gives C. Is an elementary reaction. In an experiment involving this reaction, the initial partial pressure of A is, what is the initial pressure of A? 0.4 and is 1, C is 0. This is initially. When the pressure of C becomes 0.3, after T time, this became 0.3. Means 1 mole of A can give 1 mole of C. 0.3 moles of C formed means 0.4 minus 0.3. Out of 0.4 moles or pressure. Pressure can be taken in the form of moles, no problem. Out of 0.4 and 0.3 already dissociated. Whereas here, 1 mole of A can react with 2 moles of B. So therefore, 1 minus this is 0.6. Therefore, after T time, this is 0.1, this is 0.4, 1 minus 0.6 is 0.4, and the C is clear the 0.3. Then what you have to find here, the reaction, the rate of the reaction relative to the initial one. And the new rate is equal to, so concentration of A 0.1 power 1 into 0.4 whole square. And the next one is initial rate is equal to, initially how much is there? The 0.4 into, and the 1 is there, 1 whole square. Therefore, new rate to initial rate. The new rate to clear the initial rate. How much? Simply, the new rate is 0.1 into 0.16 divided by 0.4 into 1. So therefore here, the 4 ones, 0 fours. So 1 by 4 by 100, which is equal to 1 by 25. So therefore, the new rate is the 1 by 25. So this is your correct option. The next one is question number 173. Calculate the delta G naught at 127 degrees centigrade for a reaction with K equilibrium. So generally from thermodynamics, delta G is equal to delta G naught plus 2.303 RT, clear the L log QC, reaction quotient. At equilibrium, delta G is equal to 0. QC will become equal to Kc. Therefore, 0 is equal to delta G naught plus 2.303 RT log. The QC becomes Kc. Now, we have to calculate the delta G naught value. Therefore, delta G naught is equal to minus 2.303 R. R is 8.314, because R value must be taken in joules, into T is 127 degrees centigrade. So T is equal to 127 plus 273, and this is 400 log. The Kc is 10 power 3. So therefore, delta G naught is equal to minus 2.303 into 8.314 into 400 log 10 power 3. So minus 2.303 into 8.314 into 400 into log 10 power 3 is equal to 3 log 10, which is equal to simply clear the 1. 3 log 10 is equal to 1. And this many clear the joules we get. This many joules we get, but we have to convert into kilojoules. Therefore, delta G naught is equal to minus 2.303 into 8.314 into 400 into 3 into 10 power minus 3 kilojoules. Then if you simplify this one, so we get minus 38.294 where the kilojoules. So this is your answer. Therefore, the first option is correct. Next one, question number 174. No. Select the rate law that corresponds to the data shown for the reaction. Here A, B, and C given. A and B reactants, C is product. See carefully. Now, from here concentration of A 0.1 to 0.024, 0.024, 0.012. Whereas here 0.035 like this. So 1 to 4 concentration of A, see carefully, 1 to 4 concentration of A is constant, but here concentration of A increased by 2 times. Concentration of A increased by 2 times. Here the constant, here 2 times. As the concentration of A increased 2 times, the product, this is C is product, increased by how many times? 8 times, which is equal to 2Q. As the concentration of B increased by 2 times, rate of formation of product increased by 8 times, which is equal to 2 power 3 times. Therefore, order with respect to B is 3. Order with respect to B is 3. This is the third order reaction. Next one, we'll see with respect to A. For example, here, in this one, concentration of B is constant, but here the concentration of B increased by how many times? 2 times. See, concentration of B constant, concentration of A increased by 2 times, but here rate is constant. As the concentration of A increased by 2 times, rate of formation of C is constant. There is no change in the rate of formation. Therefore, order with respect to B is 3, we know. Therefore, order with respect to A is 0, and the rate law is equal to K into concentration of A power 0, B power 3. Concentration of A power 0 means only concentration of B power 3. So therefore, first option is the correct option. And the next one is question number 175. Which of the following is secondary pollutant? So here, these 3 are primary pollutants of photochemical smog. PAN is secondary pollutant. Here, these 2 will affect directly, but this is produced peroxyacetyl nitrate. This is peroxyacetyl nitrate is produced in photochemical smog, and this is secondary pollutant. Its effect is more. Peroxyacetyl nitrate OO, and this is NO3 minus this is called PAN. This is simply secondary pollutant. So these will directly affect when here hydrocarbons combine with oxidizing agents like ozone and NO2. Peroxyacetyl nitrate is formed. This is secondary, the pollutant. So therefore, our answer is PAN. Next one, question number 176. The toluene, the first one is methyl benzene is given toluene. When reacted with CrO2, Cl2, carbon disulfide and H3O plus, this is called Itard reaction. This is called simply Itard reaction. The product is benzaldehyde, one of the most important preparations of benzaldehyde. Next one is the OH minus, this is base. And the product B is formed. Now, what is the product here? This is benzaldehyde, no alpha hydrogens. Therefore, second reaction is Canizaro's reaction. Second reaction is Canizaro's reaction. The product is CH2OH plus and COO minus. Disproportionation reaction takes place. One aldehyde undergoes oxidation, one aldehyde undergoes simply reduction. The A to B, this reaction is, which reaction? Simply the Canizaro's reaction. Okay. So here, first reaction is Itard reaction, A to B is Canizaro's reaction. Therefore, your answer is correct option, first option. Canizaro's reaction is a disproportionation reaction. The very, very important one is migration of H minus will involve in Canizaro's reaction. Migration of H minus will involve in Canizaro's reaction. And the question number 167. Calgon used as a water softener is. So which of the following is calgon? Generally we know the calgon is sodium hexametaphosphate. Sodium hexametaphosphate, Na6P6O18. Then what is the actual form of the calgon means? The actual form of calgon is Na2 Na4 PO3 taken 6 dissociates to give 2 Na plus Na4 PO3 taken 6 minus 2. So here this will remove the hardness of water. When hot water which contains Ca plus 2 and Mg plus 2 pass through this, only these ions, not outside Na plus ions, these ions will help in the removal of hardness of water. We get Ca2PO3 taken 6 and minus 2, like this one, or magnesium, either calcium or magnesium ions. Sodium, these sodium ions replaced by calcium and magnesium. Therefore, calgon removes hardness of water by complex formation. Calgon, this is actual form of calgon, removes hardness by complex formation. Okay, so therefore the answer is first option. Please, this is very important one. And the next one is question number 178. The calcium crystallizes in FCC centered cubic lattice. The calcium has FCC crystal lattice. With unit cell edge length is A is equal to 0.556 nanometer. Suppose the sample of Ca plus contained 0.1% Frankel defects. Ca has 0.1% Frankel defect. Frankel defect in the crystal. The density of the crystal is, now very, very important point is, what is the Frankel defect? The Frankel defect is only displacement defect or dislocation defect. This is dislocation defect. Dislocation defect. Dislocation defect means if you take any FCC unit cell, the calcium atoms must be at the lattice points, corners, as well as face centers, like this one. But due to Frankel defect, instead of occupying lattice points, these atoms occupy interstitial spaces. Instead of occupying lattice points, the interstitial, the voids will be occupied by the ions. Therefore, in the Frankel defect, no change in the density. Frankel defect will not affect density. When the Schottky defect is there, density will change. But Frankel defect will not alter density. Therefore, your answer, no need to calculate anything. So whatever may be the crystal defects, percentage of defect is there. And in the Frankel defect, the density will not be affected. That's why density does not change is the correct option. Next one is question number 179. Which of the following does not give Hoffman bromamide reaction? So Hoffman bromide reaction. So this reaction is clear, the Hoffman bromamide reaction given by, this reaction is to prepare only primary amines. This reaction is used to prepare only primary amines, both aliphatic and aromatic primary amines. So here in this reaction, so for example here RC double bond O NH2 is there. So in this one, when react with simply NaOH plus Br2, half one bromide reaction, CO is eliminated, product is R NH2. This is primary amine is formed, and R can be alkyl or simply aryl group. So here NH2 will be attached to this, here NH attached to this one, here also NH2 attached to this one. But here when NH attached to this one, here the secondary in this one, the secondary amine is formed. How secondary amine? Already nitrogen attached to one methyl group. When nitrogen attached to this one, we get secondary amine is formed. Therefore, this one will not give Hoffman bromide reaction. Very important one here. The Hoffman bromide reaction is used to prepare only primary amines, both aliphatic and aromatic primary amines. Here already nitrogen has one methyl group, so second carbon cannot be attached here. This will not give the Hoffman bromide reaction. And the question number 180. Now, name the metal M which is extracted based on the following equations. See, this is extraction of gold. This method is used. This method is cyanide process, MacArthur cyanide process or cyanamide process, used to extract Ag and Au. Used to extract Ag and Au. So here, when you take metal Ag or Au, we get simply Ag or Au, we get coordination number 2. Then here, this is metal Ag or Au, then here zinc, then here metal is Ag or Au. Two cases, the metal is their coordination number 2, when the zinc is their coordination number 4. Metal is their coordination number 2, zinc is their coordination number 4. So that's why your answer is clear, the Au. This is called MacArthur cyanide process. Okay, the coordination number when metal is there 2 only, but zinc is their coordination changes to clear the 4. Metal is first oxidized, then metal is simply reduced. So therefore, this method is special method. First given metal is converted oxidized, then the metal is again metal ion is simply reduced. So oxidation and reduction, both the reactions involved in this one important question. The coordination number in case of metal is 2, and the coordination number is 4 in case of clear the zinc. Here coordination number is 4 in case of zinc. So therefore, your answer is clear the second option. Next one. Question number 81. Now here, the correct stability order of oxides of halogens. This is very important one. Exceptional order will be specifically here. In this one, oxides of iodine most stable due to high polarization. Then chlorine, this is due to high electronegativity, and the bromine oxides least. This is the stability order of oxides, very, very important. Due to high polarization, iodine oxides are most stable. Due to high electronegativity, chlorine oxides are most stable. So therefore, iodine, chlorine, bromine, this is the correct option. And the question number 182. Now, the order of acidity of positions X, Y, and Z. X, Y, and Z. So here, this is fluorine. 2 hydrogens are there, acidic hydrogens. 2 hydrogens are there, acidic hydrogens. Now, the H is phenol more acidic. Therefore, X is the first one more acidic. This is clear, X is more acidic only. But in the Y and Z, the which is clear the more acidic. Y and Z, which is more acidic here. This is Y and this is simply here the Z. Now you see, look at here. Now, if we remove H plus from here, we get negative charge. If we remove H plus from here, we get negative charge. If we remove H plus from here also, we get negative charge. Whichever is more stable, you see. For example, here the negative charge is there here. Now this bond will migrate here. This bond will migrate here. This bond will migrate here. This bond will migrate to this. Therefore, this NO2 effect will be there on Y. Effect of NO2 is present on Y. This is electron withdrawing group minus mesomeric effect is there. The minus mesomeric effect linked to Z, linked to Y. Therefore, Y is more acidic. But whereas here, this migrates here, this bond will migrate this side. As this bond migrates this one, it comes like this one. But this group is plus mesomeric effect will decrease the acidic strength. The mesomeric effect group is present on this one, like this one directly, and the minus mesomeric effect group is acting on this one. Therefore, Y is more acidic than simply here the Z. So therefore, X, Y, Z means third option is correct option. Question number 183. Now, the order of reactivity of SN1 of the following halides. Generally, as the stability of carbocation is more, as the stability of carbocation more, reactivity also more towards SN1 reaction. Among these, here this is third one is most stable carbocation, two phenyl groups are there, methyl group is there. Third one is most stable, therefore more reactive. Next one is two phenyl groups are there, here on two phenyl groups are there, therefore second one more. Next one, this is secondary and this one is tertiary, therefore first one and the least one is the fourth one. Therefore, the stability of carbocation more, reactivity also more. If the two benzyl groups, one methyl group is there, two benzyl groups are there, only two methyl groups are there, three methyl groups are there. So therefore, 3, 2, 1, 4. Therefore, the correct option is the second option. Next one is question number 184. The disaccharide which on hydrolysis gives beta D galactose and the beta D glucose. So here, when the lactose C12H22O11, this is that the lactose when subjected to hydrolysis, we get simply clear that two units are obtained. One is beta D galactose plus beta D glucose. And here the lactose has C1C4, which are here the glycosidic linkage, C1C4 glycosidic linkage between beta D plus galactose and beta D plus the glucose. Beta D plus galactose and the beta D plus glucose. So therefore, your answer is the lactose. Next one is question number 185. The incorrect statement is, so in this one, when the crystals of NaCl are heated, in the atmosphere of sodium vapor, it appears yellow due to F centers. Yes, correct only. This is called metal excess defect. So 185, the first option, here the correct statement only. And the next one is O2 is paramagnetic. This statement correct. O2 is paramagnetic. CrO2 is ferromagnetic. MO is antiferro. Yes, the statement as it is correct one. Fact. The certain oxides VO, VO2, VO3 and TiO3 show metallic properties at all. No, not at all temperatures. Only at specific temperatures they show. Therefore, this statement is incorrect statement. This is wrong. Only particular statements only. So they show metallic properties, not at all the temperatures. That's why the third statement is simply incorrect statement. Question number 186. Now, identify the incorrect set related to oxidation states of central atom. The first one, Br3O8. We should find the oxidation state of central atom. If you see the structure of this, BRO, BRO, BRO. Next one is Br double bond O, double bond O. Br double bond O, double bond O, double bond O. Br3O8. See, -2, -2, -2. That's why +6. -2, -2, +4. 3 oxygens are there, -2, -2, -2, at +6. Therefore, the by +6, +4, +6, +6, +4, +6. The first one correct only. Incorrect set we have to find. C3O2. Carbon suboxide. O double bond C, double bond C, double bond CO. This is -2, +2, 0, +2, and -2. Therefore, 2, 0, 2. Yes, correct only. And third one is N3H, H plus, N3 minus. In N3 minus, N double bond, N double bond, N. This is 1, 2 lone pairs, 2 lone pairs. Here, no lone pair at all. Therefore, charge on this one, -1, -1. This one is +1. Central nitrogen has +1. These two -1, -1. So, therefore, this is wrong. Incorrect match is this one. And here, S4O6. S4O6 -2 tetrathionate, S double bond O, double bond O, O minus, S double bond O, double bond O, O minus. Therefore, -2, -2, -1, +5. Sulfur, sulfur 0, sulfur, sulfur 0, -2, -2, -1, +5. Therefore, so +5, 0, 0, +5, this one also correct only. So therefore, your option is third option. Question number 187. Para-nitrotoluene react with a bromine Fe. Okay. Next one. Then first one, bromination. The next one is simply here the reduction reaction. Then the benzene diazonium chloride. And the next one is the finally S3PO2 and KMNO4. Then what is the product obtained? First one, the bromination, if you see, clear the bromination, clear the, if you see. The product is CH3 is ortho-para-directing, NO2 is meta-directing. When the bromine iron is taken, bromination, this is ortho-para-directing, this is NO, meta-directing. That's why the bromine attacks the common position. This one is bromine and this is simply NO2. Next one, SnHCl. When SnHCl is taken, NO2 is converted into aniline. Nitrobenzene is reduced to clear the aniline here, bromine. This is simply NH2. And the next one, NaNO2HCl. This is diazodization reaction, 0 to 5 degrees centigrade. This is 273 to 278 Kelvin. Both are same. The product is Diazonium ion, CH3Br, and here it is N triple bond N plus Cl minus, diazonium ion, which are reacting with H3PO2 hypophosphorus acid. This group is replaced by H plus. The reaction is reduction reaction. CH3 and bromine. Okay, this is the first one is A, this is B, and this one C, and this one D with KMNO4. KMNO4 can oxidize methyl group 2 benzoic acid. Therefore, COOH is obtained. This is simply bromine. Therefore, what is the name of the compound? 2-bromo-benzoic acid is formed. What is this one? 2-bromo-benzoic acid. Therefore, your answer is correct option, first option. Question number 188. The incorrect statement is, again, the incorrect statement we have to write. Now, an aqueous solution of borax is used as buffer solution. Yes, the aqueous solution of the borax is used as simply here the buffer solution, the correct only. And the next one is solubility of AgBr is more in aqueous ammonia than in pure water. And next one, yes, aqueous solution of borax. Borax is Na2B4O7.10H2O, the borax. So here the aqueous solution of borax is basic, and this is weak acid and strong base will be there. So that's why it acts as a buffer. It's correct only. Solubility of AgBr is more in aqueous NH3 than pure water. If the AgBr is taken, ammonia is taken here. AgBr can form complex with ammonia. AgBr taken twice, and next one is Br minus. Therefore, as the ammonia forms complex, solubility increases. Solubility increases. Therefore, first statement correct, second statement also correct only. Aqueous solution of CH3COOH has a pH the less than 7. No, both are weak only, and the pH is equal to 7 will be there. So therefore, here this is not correct statement. This is your correct answer here. This is not correct statement because the weak acid and weak base, the pH cannot be less than 7. pH is equal to 7. So therefore, third option is incorrect option. Next one. Question number 189. The fluoride of xenon, which undergoes disproportionate reaction with water. Generally here, xenon tetrafluoride, when subjected to hydrolysis, the product is XeO3 plus xenon plus HF is formed. So xenon trioxide, xenon is in +6 oxidation state, 0. And here this is simply +4. +4 to +6 is oxidation. And the +4 to 0 is, this is simply the reduction reaction. This is oxidation and this is simply the reduction reaction. So therefore, this reaction is called disproportionation reaction. This reaction is called simply disproportionate reaction. Therefore, xenon tetrafluoride undergoes disproportionation reaction. Therefore, first option is correct option. Now, question number 190. The correct arrangement of electrons in COH2O taken 6 plus 3. Here, in this case, in case of cobalt +3, exceptional case, here H2O acts as strong field ligand. Therefore, pairing takes place. Pairing takes place. Therefore, pairing takes place. That's why. Now here, the cobalt +3. Cobalt +3 means cobalt is 3d7, 4s2. Cobalt +3, 3d6, 4s0. Now, and here 1, 2, 3, 4, 5, 6. An octahedral complex splits into two groups. This is EG and T2G. The strong field ligand, therefore pairing takes place. Actually, here H2O weak field ligand, but here it acts as strong field ligand. So the first electron, second electron, third electron, fourth electron, fifth electron, sixth electron. So therefore, the T2G6 EG0. The configuration is the T2G6 and EG0 is your correct option. This exceptional case, H2 acts as strong field ligand. Basically, H2 is weak field ligand, but in the cobalt plus 3, H2 acts as strong field, pairing takes place. Which of the following give 5-keto 2-methyl hexanol upon reductive ozonolysis? So very simple here. When subjected to reductive ozonolysis, what is the product here? The product should be 5-keto. Just you break the bond here. Then the first one will give double bond O. Double bond O. Diketone is formed, but 5-keto 2-methyl hexanol. Aldehyde should be there. So therefore, 2 ketones are there. Second option, if you break the bond here, CH3 double bond O, CH3 double bond O, H. This is ketone and aldehyde both are there. 1, 2, 3, 4, 5, 6. 5-keto, yes, 5-keto. 2-methyl, hexanol. Therefore, second one will give 5-keto 2-methyl hexanol. Just you break the bond, you write the product. You break the bond, you write the product here. You write one oxygen here, one oxygen here. Here also one oxygen, one oxygen. This is clear that diketone. The first one is diketone is obtained, ruled out. Second one, aldehyde on first carbon, keto on fifth carbon, methyl is on second carbon. Therefore, your answer is second option. Question number 192. Calculate the pH at which magnesium hydroxide begins to precipitate from solution containing 0.1 m magnesium plus 2 ions. Ksp of magnesium hydroxide is, if KIP is equal to KSP, ionic product is equal to KSP, PPT formation will start. Now, KSP of magnesium hydroxide is 1 into 10 power minus 11. So KSP of magnesium hydroxide is equal to magnesium plus 2 concentration into OH minus whole square. Now, magnesium plus 2 concentration given 0.1, that is 1 into 10 power minus 11 is equal to Mg plus 2 concentration is 0.1 into OH minus whole square. Then this is OH minus whole square is equal to 10 power minus 10, and OH minus concentration is equal to under root of 10 power minus 10, which is equal to 10 power minus 5. As 10 power minus 5, OH minus, therefore POH is equal to minus log OH minus concentration is equal to, so minus log 10 power minus 5 is equal to 5. As the POH is 5, therefore pH is equal to 14 minus 5, which is equal to 9. So that's why the pH is equal to 9. So therefore the option is fourth option. And question number 193. At 821 ml of nitrogen was collected over liquid water at 300 Kelvin and 1 atmosphere pressure. If the vapor pressure of H2 is 30 torr, then moles of nitrogen in moist gas mixture is. So here, volume of nitrogen is 821 ml, which is equal to 0.821 liters. Pressure of moist nitrogen is 1 atmosphere, which is equal to 760 torr. Pressure of H2O, this is called aqueous tension. Aqueous tension is equal to 30 torr. Therefore, pressure of dinitrogen is equal to 760 minus 30, which is equal to 730, which is equal to 730 by 760 atmospheres. The temperature is 300 Kelvin. Number of moles of nitrogen, how much? Number of moles of nitrogen, how much? PV is equal to N into R into T. The pressure is 730 by 760. Volume is 0.821 into number of moles, R is 0.0821 into, clear the R, temperature is 300 Kelvin. So you have to find the N value here. So therefore here, if you simplify, then here 0.821 is there, 0.081 is there. And if you simplify here, we get N is equal to 0.032. N is equal to 0.032 means this is correct option. Okay. Next one. Question number 194. The rate of diffusion of sample of ozonized oxygen. Ozonized oxygen is O2 plus O3. Is rate of diffusion of O2 plus O3 is 0.98 times that of pure oxygen. 0.98 into rate of diffusion of the oxygen. The percentage by volume of ozone in the ozonate sample. The percentage volume of ozone we have to find. So therefore, rate of diffusion of O2 plus O3 by rate of diffusion of O2 is equal to under root of molecular weight of O2 by molecular weight of O2 plus O3. Now, rate of diffusion of O2 plus O3, 0.98 rate of diffusion of O2 by rate of diffusion of O2. Molecular weight of O2 is 32 and this one we don't know M. So O2 cancel. 0.98 into 0.98 is equal to 32 by M. So M is equal to 32 by 0.98 into 0.98. This is molecular weight, average molecular weight, average molecular weight. Then percentage of O3 is X, percentage of O2 is 100 minus X. Therefore, X into molecular weight of ozone 48 plus 100 minus X into molecular weight 32. X into 48 plus 100 minus X into 32, clear that, is equal to, okay, this is the molecular weight is 32 by 0.98 into 0.98. And if you simplify this one, then we get the X value. This X value is the X is equal to the 8.25 we get here. X value is simply 8.25. If you simplify, you get X value as simply 8.25. So therefore, your correct option is the second option. We have calculated the molecular weight of the ozonized oxygen, and from this one we have calculated the percentage X. So therefore, your answer is 8.25. Next one is Question number 195. Now, incorrect statement regarding H2 and D2 is. So, which is the incorrect statement regarding H2 and the D2 is? So, HH bonds weaker than DD bonds is correct only. D2 more denser than H2 also correct only. Internuclear distance of H2 is more than no. So, HH distance is equal to the DD distance. So, therefore, this is incorrect. Your option is the third option. So, only in hydrogen and deuterium, the internuclear distance will be same. Okay, na? Internuclear distance will be same. So therefore, third one is your correct option. Question number 196. Now, the acidic strength of the compounds, the first one is acidic nature, second one also acidic nature, and the third one basic nature, fourth one. So formic acid, benzoic acid, and acetic acid, correct only. Generally, aromatic acids are more acidic than aliphatic acid, except formic acid. Therefore, first statement, clear the correct only. And next one is trifluoroacetic acid, trichloroacetic acid, NO2. Three groups are there. So, therefore, this one also correct only, 196. And the next one is N-methyl. This is N-methyl methanamine. N-methyl methanamine. N-methyl and the methanamine. This is basic strength order. Methanamine, CH3, NH2, and N-N, diethyl methanamine. This is N-N. This is N-N, dimethyl, CH3, and next one is CH2, CH3. This is tertiary in which solution? Aqueous solution. Yes, tertiary in aqueous solution is less. In anhydrous state, this will be more, but in aqueous solution less. Therefore, third statement also correct only. Okay. So, first statement correct only, second statement correct only, third statement correct only. N-diethyl ethanamine. No, this is tertiary is there. So, therefore, this is least basic. Fourth one wrong. Therefore, your correct option is first one, second one, third one. All the three correct only. First, second, third means third option is your correct option. And the question number 197. Which of the following is not an essential amino acid? So here tryptophan, histidine, proline, and threonine. That this is memory based here. The proline is clear, the not an essential amino acid. This is essential amino acid here. This is H. This is clear, the NH. This one is secondary amino acid. This is only the one secondary amino. All the amino acids are primary, but only this amino acid is simply secondary amino acid. So this is not an clear the essential amino acid, and this is very important one. This amino proline is secondary amino acid. In all the 20 amino acids, this is only the secondary amino acid here. Okay, and the question number 198. Which of the following ethers cannot be prepared by Williamson synthesis? So here, if you take CH3O, CH3, and CH3. So here, this one, the methyl group is there, we can prepare. When it is attached to benzene ring here, one side is tertiary ether, tertiary alkyl halide cannot be taken. And next one, and if you want to prepare tertiary alkyl halide, tertiary alkoxide must be taken, but not tertiary alkyl halide. So therefore here, this ether, either you have to take tertiary alkyl halide CH3, Br plus O minus Na plus must be taken. So this will give, instead of this product here, then what do you get here? CH3, double bond CH2 we get. So therefore, this tertiary ether, phenyl tertiary ether cannot be prepared by Williamson synthesis. Okay. So whenever, if you want to prepare tertiary ether, tertiary alkoxide must be taken, but not tertiary alkyl halide. To prepare tertiary ether, tertiary alkoxide must be taken, but not tertiary alkyl halide. So here we need to take tertiary alkyl halide, which gives alkene. Therefore, this ether cannot be prepared by Williamson synthesis. Question number 199. The products formed when dilute HNO3 react with copper and zinc. When the copper reacts with HNO3 dilute, then the product is CuNO3 taken twice plus NO plus H2O, and the Zn HNO3 when react with the dilute HNO3, Zn NO3 taken twice plus N2O plus H2O. First one is nitric oxide, second one is nitrous oxide. First one is nitric, second one nitrous oxide, second one is correct one. But the concentrate HNO3, if we take concentrate HNO3, always gives which one? NO2 will be given here. So dilute will give, copper will give NO, zinc will give N2O. But when you take concentrate HNO3, NO2 is produced here. Okay. The next one is question number 200. The graph between log x by m versus log p is in atmosphere is provided for adsorption of ammonia gas on metal surface. Calculate the weight of ammonia gas adsorbed by 50 grams of metal surface at 2 atmosphere pressure. Actually here, this is Freundlich adsorption isotherm. Freundlich adsorption isotherm. X by m is equal to k into p power 1 by n. Log x by m is equal to log k plus 1 by n log p. This equation is of the form y is equal to mx plus c. The intercept c is equal to, this is c is equal to 0.3. Therefore, log k is equal to 0.3 and the p is equal to 2 atmosphere. P is equal to 2 atmosphere and the slope m is equal to 1 by n is equal to tan 45 degrees is equal to 1. Slope m is equal to 1, tan 45 is equal to 1. Now we have to find the x by m per gram. So x by m is equal to log k is 0.3 plus 1 by n is 1 and the log clear the 2. So therefore, what can you write here? X by m is equal to 0.3 is, we can take it as 0.3 plus log 2 is 0.3. X by m is equal to 0.6. X by m is equal to simply 0.6. Now, this is per 1 gram. But in the question, we have to find for how many grams? We should find it for 50 grams. For 1 gram, 0.6. Per 1 gram, 0.6 grams absorbed. For 50 grams, how much? So this is 50 into 0.6. So therefore here answer is 30. So this 50 grams of metal surface, 200 atmosphere pressure. Okay, the pressure is 2 atmosphere. Now 0.3 mx slope is log k is equal to 0.3 and next one is log 2 0.6. X by m is equal to, x by m is 0.6. Here, sorry, log x by m, log x by m, log x by m is equal to 0.6 and this is So 0.6 means log x by m is equal to log 4. You take anti-log both the sides, x by m is equal to 4. This is per gram. This is per the gram. Per gram, how many? 4 grams. For 50 grams, how much? The 50 into 4 is the 200 grams. Therefore, your answer is 200 grams. So the answer is 200 grams. So here, so thank you to all, and I wish you all the best to all. Thank you.